Okay, thank you all so much for having me. I'm really excited to be here. I'm excited to talk to you all today. Um, the title of my talk today is Slowly and Then All at Once, which at least for me, I think kind of encapsulates the way that I've been feeling about a lot of the progress in AI, especially most recently with coding agents and all of the progress that we've seen over the last 3 to 4 months. And for this talk, I really wanted to kind of start pretty broad, share a survey of what I've personally seen in this field with AI agents over the last 3 years and a little bit before then. And then actually spend a lot of time, the majority of the time, sharing a glimpse into what I think the next 3 years might look like what the future might have in store for all of us. And obviously, the big caveat there is there's one thing I've learned uh, about AI most recently. It's extremely hard to predict what's going to happen in the future, but I think we can try and glimpse a little bit. Um, so a little bit more about me. Yeah. So I currently work at OpenAI. I lead engineering for our API teams, our platform teams. For those of you not familiar, just to share a little bit more about what the API is. So OpenAI really has, I would say, three main products right now. The biggest product that we have is probably, the one that you all know about already, which is ChatGPT. It's a consumer app. It's a web app that you can use to talk to our models. The second product, which is getting a lot of traction now, is called Codex, which is a coding agent, software engineering coding agent that you can run in your terminal, that you can run on your computer. It'll help build code for you, write code for you, and build things for you. And then the third product that we own and that we sell is what we call our API, and that's what I work on. And so the API is a developer-focused product. We basically expose a bunch of endpoints that developers can use to integrate our technology into their own products. And so I've had the privilege of working on this for quite a long time, long in a relative sense, but for around, 3.5 years. And my favorite part of my job is because it's a very developer-oriented product, there are lots of startups and companies, as well as research institutions, universities, educational institutions that use our APIs to build things on top of. So while, you and I or like my mom might use ChatGPT for her daily life and for looking things up. The customers that I work with on the API tend to be a lot more oriented around work, around businesses, around the enterprise. And so think like, working with a company like Uber or like T-Mobile to build things for themselves, working with research labs who are using our APIs to do interesting research and publish things. Those are the kinds of customers that I've primarily worked with. And because of that, I feel like I've had a very broad view of how this space has changed over the last 3.5 years and beyond. And it has changed pretty significantly. And so that's kind of the background that I was bringing to this. And I was hoping to ideally share something new that folks weren't aware of and then use that information to inform where I think things are going here. So my agenda today is pretty simple. I was going to talk about the past 3 years. I kind of think about it in three different eras. There's the pre-ChatGPT LLM era, which is basically 2019-ish all the way up to 2022. Then there's what I call the ChatGPT era, which started when ChatGPT launched in November 2022. And I think it actually continued all the way up until late 2024, which is when we started seeing the reasoning models come in. And then I think that era is the one that we're currently in right now. We're seeing the reasoning models, the models that can think before they respond to you, play out from late 2024 to present day. And so the majority of the talk will be around what I think might happen in the future and what the future might look like from here. To anchor this talk, I'm going to be using this chart or this graph, which is one of my favorite graphs. So some of you may have seen it before. It's made by an organization called Meter, METR, and it is a really interesting way of evaluating the models and the trends of what is happening right now. So this is a graph that shows on the x-axis is just time, so it's the release date of an LLM. and the y-axis shows how long of a task how long of a software engineering task, so it's scoped to software engineering, the LLM can complete 50% of the time. And so what this really is showing is a chart of how long these agents can run and do coherent work for you. And I really, really like this chart because I actually think of all the different graphs and evals and all of that that are out there, this chart most clearly represents what I think is happening right now. And in particular, this crazy exponential curve that we're currently on. And actually, if you look a little closer, we're actually ahead of the exponential now with the more recent changes. And so I'll obviously go into more detail on this slide, but I think thinking about the world in this framing really helps anchor a bit more of what's actually happening, what especially has happened in the last 3 to 4 months. And so to kick things off, so pre-ChatGPT. So on this chart, pre-ChatGPT is this giant area on the left half of the chart. So 2019 all the way to late 2022. I've been following AI and working in ML this whole time, but I think not a lot of people had actually been following what was happening with GPT and those models back in 2019 or 2020. But the interesting thing to reflect on is how there have always been quite a few through lines through the entire industry since the very beginning, since 2019. So the one observation I have is that the AI field and the industry in general has actually always been in pursuit of something that would help humans do things. So the idea of AI eventually augmenting and helping humans and doing useful, economically valuable tasks for us has been ingrained in the field since day one, and you actually can see sparks of it in the very beginning. To illustrate this, one of my favorite videos that actually we share a lot internally is this interview between our CEO Sam and a VC at this conference called Strictly VC. This was in 2019. So kind of going back to say, this is like far left side of this chart. GPT-2, I think, had just gotten launched. And the interviewer basically asked Sam, like, oh, OpenAI is obviously a nonprofit, but you need to make business, you need to make money somehow. And so what's the business plan for OpenAI back in 2019? And then Sam answered with a straight face. He basically said, we're building AGI, and the plan is once we have it, we're going to ask the AGI how to make us money, like what the business plan should be. And he says with a straight face, everyone laughs at him. And then the screenshot is, right after he says that, when his interviewer, laughs in his face. But I think I really like the clip because it shows how remarkably consistent the desire and the vision of AI has been, but also how crazy it sounded just 7 years ago, less than 7 years ago. Whereas now it doesn't sound that crazy. It still sounds a little crazy, but it doesn't sound that crazy to ask an AI, to ask ChatGPT or ask one of these models, what a good business plan could be, or even to have it help out in work. And so the pre-ChatGPT era, I think of as having two big milestones. First one is the launch of GPT-2 in 2019. This was the paper that we had published back then. The original GPT-1 paper obviously was useful, but it very much was like an early release. The model itself wasn't actually doing that many interesting things. And the GPT-2 launch was very interesting because it was actually the first time where OpenAI did not release the weights of the model publicly because we had a lot of worries about how it would be used. And just to give a sense of the capabilities of these models at this time. So this was a chart from the paper. This is no longer mind-blowing to us now. This is table stakes to be able to do simple Q&A. Here we've actually saturated most of the Q&A evals at this point. This is what the world looked like with GPT-2. So and at the time, this was mind-blowingly impressive. The fact that it had this much information encoded into its weights, and the fact that you could actually train a model to be this good at something, an autoregressive language model, you could train it to be this good at something just by training it on bulk data from the internet. And so this chart was super surprising to people at the time. But again, it was very simple, right? And if you look back and you think back on the meter chart, how long of a task are we really asking the model to do here? It's literally, instantaneous. The next two tokens after you ask, who wrote the book, The Origin of Species, you're basically done with the task. It's just answering Charles Darwin. And so symbol Q&A was like basically starting to emerge here. Um, the next milestone in my mind was the launch of GPT-3, which is when we massively scaled up these models from the GPT-2 era to an order of magnitude larger models, amount of data and compute that we were throwing into these things. And so this was 2020. And from my perspective, GPT-3 was when things really started getting interesting because things started getting commercialized. So with GPT-2, this is kind of hard to commercialize. It's really just like a half good trivia bot that could answer things for you, but only 70% of the time. But with GPT-3, it started reaching a point where the models could actually complete quite a few things and actually start doing interesting economic work. And that is when OpenAI launched the API. So this is, my beloved product that originated technically less than 6 years ago in 2020 when it was launched. But it was the first time that one of these models had been productionized and put into the real world for use by other people. The interesting thing was at the time, OpenAI itself had no idea how to productionize this technology. And so it created an API to help other people productionize the technology because we didn't know what to do ourselves. And so the API back then was extremely simple. So it was, because these models are all autoregressive, you give it an input and it completes it for you. That's exactly the shape of the API that it had. It was like, give me some text. So this is a sample API request from the very first version of the API. Give me a prompt. So an example of Q&A format, and then a question: what is the meaning of life? And the model will give you a completion. And again, this is very similar to kind of the Q&A style work that GPT-2 had, but it's now suddenly available. And even then, I think the thread of like trying to have these things do work for you was kind of alive. But the examples were all toy examples. So this is also from the launch of the API, where you could in Excel create just a row that says company ticker year founded, and then have it autocomplete the rows of the table using GPT-3. And so in this case, it completed Apple, the ticker, and then the year founded, as well as looks like seven other examples. And so again, it was just kind of completing things. This could be useful, but we were kind of already exploring with surfaces. And if anyone has used one of the AI models for Excel, you can see how far we've come with these things. But again, it was just very simple and completions oriented back then. The playground, the way in which the UI, web UI, which kind of predated ChatGPT, was just a simple text box. All you could do is enter in text, submit, and then it would complete it for you. And so, we started really from very simple things. But because GPT-3 had actually gotten pretty like reasonably smart, there were actually applications that could be built on this. And so, back in this like 2020 era, the like completion-based world, most applications kind of just fell out of the model itself, and they were also very autocomplete focused. And so at this time, basically, I think 2021, 2022, the state of the AI industry and the applications built on it were very simple, but the two biggest ones were very straightforward applications of the technology. They were copywriting startups. So there is a company called Copy AI and Jasper. They still exist. But back in 2021, 2022, they were doing copywriting. So their product was basically use GPT-3 and help it write email copy or marketing copy. And they were the biggest users on the API at the time. I remember, looking at our top API customers, it was just Copy AI, Jasper 1 and 2, and then a huge gap, and then a bunch of other, kind of like science projects that other people were working on. So they were kind of the main ones. And the interesting observation here for me is, and I think this has stayed true over time, is the applications that we've seen as this technology has evolved had a tendency to just slightly be downstream of the model capabilities themselves. So basically, as the model capabilities evolve, the applications themselves evolve. And I think that's what we've seen most recently. And the product itself just ended up being a pretty thin layer on top of the model. There's obviously innovation that needs to be done there, but it was really the model itself that was the core of the application. And as the model changed, the core applications on top of it would change as well. And so that brings us to 2022, which I think of as the ChatGPT era. And this era I view as moving from just completion-based work into chatbot back and forth style application. So chat basically. And I think with that kind of paradigm change with ChatGPT, it opened up an exponentially larger market of applications, of people building things on the APIs, of things that you could do with the models, which was coupled with a further increase in the model's intelligence. And so going back to the meter chart, this is the next 2 years, or actually maybe next 2 years ish. And going from late 2022 to late 2024, which is when the first reasoning model released. And so, obviously this was kicked off by the launch of ChatGPT. I had to dig up an old screenshot of what ChatGPT looked like from a UI perspective. I forgot we launched it like this. It was very left a lot to be desired from a design perspective, but it worked. It worked, and the big change here is obviously it was still a completion-based model. It was obviously it's still an auto-aggressive large language model, but we post-trained a format so that the model understood the concept of turns. The model understood that it was waiting for a message from a user, and then it would kind of output a message. And so this like chat idea became very ingrained in the product itself. It turned out that as a product for this era, chat actually worked particularly well. But in this era, we started seeing the beginnings of what I like to think about as like agentic behavior, which is the model starting to do things for you, and the model starting to go out and kind of use tools and be productive in the world. And so this was shortly after the ChatGPT launch. We called it, we made an update in the API that we called function calling, which is, if you think about a simple chat back and forth, it's just answering your question directly. But the question is like, what if you gave it a set of tools or a set of functions? And so this is an example of how it worked. It still works this way, but the way in which it happens is now slightly different. And it's crazy because this was 3 years ago. This is now kind of maybe like an old way of you doing things. But you basically define a set of tools as a function. You give it to the model itself, and you let the model decide whether or not it wants to call it or if it wants to return just text. And so in this example, you give the model a tool called get_weather. Kind of give it a description of what it is. It gets the weather for you, given a location. And then you also give it a prompt like, what's the weather? And the model itself, will then return saying, I have an intent to call the getWeather function. Then on the developer side, we call getWeather ourselves. So, we will hit our own servers in the back end, and let's say, returns something that says temperature 14 degrees Celsius. And we then return that to the model and said, hey, we called the function that you wanted. How do you want to proceed? And then it would take that raw data and then synthesize into a final response. So this really was the very first beginnings of using functions and using tools, which is, I think, basic for the agents of today. But it really only started 3 years ago. And the first version of what this might look like in the product was actually a release that we had in March 2023 called plugins in ChatGPT. This was actually a huge deal for us at the time. My guess is most people here nowadays don't actually remember this. It was a killed feature. But plugins was a pretty straightforward application of this, and it was basically thinking, what would happen if we could have other companies kind of host some of these functions on their own servers. So Instacart, OpenTable, Wolfram Alpha could host a set of functions. They could publish it and let the model see it, and then have the model choose to call their website and call their functions if we wanted to. And we call those plugins. And it actually worked like okay. But if for those of you who remember this product, the models just weren't very smart yet. Like you couldn't really do much. This kind of showed a good glimpse, but you couldn't actually you couldn't use more than 3 plugins, which was kind of weird. You needed to explicitly kind of opt in and share which plugins you're sharing with the model, and that was kind of all you could do. And so, with that, like with just like chat and function calling, we were able to really extend the chat paradigm for a while. And it turned out the chat paradigm was surprisingly generalizable, surprisingly easy to use, and it would fit into a lot of different use cases. And so on the API, it was this era where we started seeing a crazy Cambrian explosion of startups, of companies building products on these models that would actually start being very, very useful for work. A good example of this is in coding, where so this is a screenshot of Cursor, where you'd usually have the IDE, but Cursor basically started adding a little panel on the side where you can chat about the file. And so you can ask the questions, can you name this file? You can select a function, ask it to explain it to you in a chat format, and you actually it was very, very helpful for software engineers, and still a lot of people use this. I actually use this every day still as well. You started seeing search became a very popular use case. So Perplexity was a very popular, or is a very popular search engine that's powered by our models. And turns out that in the chat format, search was a very good format as well. Yeah, so information search became a key use case in the chatbot era. But again, kind of going back to the meter chart, simple Q&A was like the shortest thing you can do. Information search and just like asking questions about content was maybe just a slight step up, right? Like when you're doing Google search, it's probably a like 1 to 2 minute task, if not a sub-minute task. And so this takes us to the current era that we're in, which is the reasoning models. To me, this is actually where everything gets exciting. And if you look at the meter chart, it kind of looks like it's on a nice exponential curve, but the way I actually think about it is it was kind of flat and growing very slowly. And then in late 2024, it started going vertical, basically. It started growing extremely quickly. And so to me, the reasoning model breakthrough is actually one of the most exciting things driving what's happening right now. And I actually think without it, we'd be in a very different world where I think we'd be having a lot more discussions around AI hitting a wall, scaling laws kind of, hitting diminishing returns. And it all really started in late 2024 with the launch of the very first reasoning model, which was O1 preview. Obviously the big breakthrough here was that we discovered at some point in 2024 that the concept of reinforcement learning could actually work to increase LM capability. This was highly, speculative at the time. And the biggest breakthrough that this introduced is another scaling dimension, which is test time compute. And so what I mean by, reinforcement learning here was the LLMs in the past, they were not trained using more traditional RL methods. And what I mean by more traditional RL methods is a training regime where you have the model act on the world and explore different ideas, and then you give it some feedback on the work that it has done. And then the model will actually learn and improve from that, right? So in classic reinforcement learning, it's an AI model kind of playing a computer game or something, and then it gets some reward based off of whether or not it won or some score that it had, and based off of that, it can learn to play the computer game better. It can learn to play Pong, Tetris, things like that better. It was highly unclear if you could do some similar setup like that, create an environment where an LLM can interact a little bit, try to solve a problem, fail a lot of the time, but sometimes succeed. And then you can then grade the model and give the model feedback in such a way that it actually makes the model it makes the model improve. And so that was kind of the big breakthrough that we had with the reasoning models. And I think the scaling dimension that we ended up being able to unlock here is basically test time compute. So inference, the inference of the model itself, having the model output more tokens, and it would actually do better. And so that is why there ended up being this whole like notion of thinking for the model, where the model will think for a little bit and then kind of produce an answer, because that thinking was the thing that was variable. That was the concept of the model exploring the world, trying all of these different things and answering more difficult questions. And then turns out you can end up scaling that, applying more compute to that. And it worked. And so for a particular task, you'd actually be able to have the model improve behavior on it. And so this is the last year and a half. It's actually only just a little bit more than a year. And the end result was basically a rapid increase in the types of tasks and the length of the tasks that these models could do. And so um, when these models started getting smarter and smarter and could start working for in this case it was shortly after this launch, the models could start doing things for like an hour long programming task or like a 3 hour long programming task. A very interesting bottleneck emerged, which I think is still a bottleneck and will still be a bottleneck in the future, which is um, the model itself could be very capable. It could keep working for a very long time, but context management ended up becoming the next big bottleneck. And so what that means is the knowledge that you're giving the model access to ended up being very, very important to what the model could and cannot do. The analogy that I have here is, as the models started becoming reasoning models, they kind of seemed like they were becoming more and more like like an intern or a college grad, basically like pretty capable people who you could deploy and do things for you. But the models themselves only exist within the context of what they can see. And so when you don't have good context management, when you don't give the model, the right things, the analogy is like if you have a really good employee or an intern or, a grad student or something, and you ask them to do work for you, but instead of them being in your business or in your lab and having access to all the information, they're kind of in a room with a computer with like no internet. And so and it's completely cut off from other data. It doesn't even, and so when you're put in a position like that, the amount of work you can do is highly limited. You're very smart, but you're in a room and you don't have any context on what you should do. So you could, maybe think for a lot, but not having context ended up being a big bottleneck. And so that's why in this area you started seeing a lot of innovation around just different ideas of how do I get the right context to the models. MCP, Model Context Protocol, was a very good first cut of this, which is like, can we actually standardize the APIs and tools, the function calls that these models get access to in such a way that there's a more standardized interface for the model to interact with a variety of different types of tools, chat interfaces, development tools, data systems, SaaS tools like productivity tools. And so MCP, kind of started emerging through this. But the models, kept getting better. And the model started reaching a point where they ended up actually being smart enough to do its own context management, right? So in MCP, you're kind of like a lot of the human intellect is done in designing the exact interface that you're giving to the model. It's very important to like design a good API. But that's again, that's kind of like that's an artifact of the old world where API design and it was kind of king with all these services of record. The model started getting smart enough where they could actually start doing their own context management. And so that's where you started having file-based context. So there's the concept of skills, which was introduced late last year. And what skills are literally just files on a file system where you basically have important information in there. You have scripts, you have assets, and you have just a guide for how the model can do things. And it's just a set of files on the file system. And the crazy thing about skills is you can actually give the model many and many of these. And you can have the model decide when and where it wants to pull those into context. And so you might have, 5 different skills, and all you need to do is tell the model, hey, you have access to these 5 different skills. Try and read skills whenever you think you need them. And the model will by itself just think about, hey, I'm trying to do this one task. Oh, it looks like this one skill is useful for me. I'm going to go upload and read the files from the skill, and then start doing my own task. And this pattern, MCP really was only like a year and a half ago, 2 years ago. We've kind of already moved on from that. It is useful, but we started reaching a world where the models started doing their own managing their own context, and skills and file-based context management ended up being very big. And we've seen this repeated pattern at this point of the models doing what I call of eating scaffolding for breakfast as they get better and better. This midwit meme, you guys may have seen it. I think it applies more than it has any right to. It's kind of a cheeky meme, but The example of kind of scaffolding, eating scaffolding for vectors, I think is what's generally happening with vector stores and data stores in general and how they interact with models. Um, so, obviously with a vector store, you take some data, some context, and you need to chunk it up, and then you create an embedding representation of it, and then you put it in the vector store so that you can do some kind of semantic search on it. And basically, as the models have gotten better, uh, we've reached a point where the need for vector stores has grown smaller and smaller, and doing just simple things like using files and like a simple grep tends to work quite well, right? So in the midwit meme, the geniuses on the right are just using files skills for everything. The anti-geniuses on the left are also just using files. It's very simple. And then in the middle, it's like you have this really complicated setup where you have the vector store and then maybe you have your own custom trained embedding model to get extra good embeddings on it. And you're using the vector store to query it. But then you also have like a re-ranker where you're re-ranking everything based off of some other knowledge that you have, just to get the right context of the model at the right time. The way that I've been thinking about this is 2 or 3 years ago when we had vector stores, what you're really doing with vector stores is you're taking intelligence and decision making from the model itself and you're encoding it into the vector store itself, right? So you're kind of doing this with the embedding model and the semantic understanding of your content. You're also doing this with whatever re-ranking you might be doing there. You're basically saying, at the time of creating the vector store, encoding a lot of information about your domain or your data set, and you're encoding it into this vector store, and you're basically having that intelligence and that understanding applied at the vector store outside of the model itself, because the model at the time was not smart enough to be able to do this. And I think the trend that we've seen, and this is the whole eating scaffolding for vectors, is the model just has gotten smarter and smarter at such a fast clip that it turns out that a lot of the time you no longer need to encode all of this understanding and intelligence and on like training wheels in the tools that the model has in the vector store. You can actually just trust the model to do a lot of this. And so this trend of like moving from vector stores to MCPs to skills, I view as a gradual trend of moving the like intelligence and decision making away from the tool in the vector store and instead putting it into the model itself and having the model do that. And so that's why nowadays you basically see like with coding agents, they're not using vector stores. If you have a coding agent and you throw it into some code base or you throw it onto your computer, it's not using vector stores to understand the code base. It's just using very simple tools. They're all files. It's using very simple tools like grep to just do simple string search. But the model has gotten smart enough where it can actually just use grep and be persistent enough to find the right information that it needs without the need of encoding all this information in the vector store itself. And so it makes it very hard for us as builders because the scaffolding isn't going away. But as the models have gotten better, this actually has ended up being a more effective way of building. And this trend of kind of moving intelligence away from the tools themselves into the models and kind of trusting the models is the general trend that I think we've seen, that I think we'll continue to see over time. And so to conclude this kind of like reasoning era, the models basically are starting to be able to do work for longer and longer tasks. It's a little hard for us to rationalize because it's moving so quickly, but we've really quickly over the last year moved from being away from just being able to do simple search tasks, Google searches or just information retrieval, to start doing actual productive work for you, which is, GPT-5 was able to start do like 3 to 4 hour long tasks. The latest frontier models like Claude Opus is like 15 hours is pretty ridiculous. Like how long these things could actually do work and actually succeed for you. And so that is when we started seeing the types of work and types of applications, again, kind of coming downstream of this, switch from being just search oriented and just lookup oriented to now start doing actual meaningfully meaty work for people. And so that brings us to today. And then the question is, what does the future hold for us? I actually think it's a very odd time to talk about the future because we're in the middle of a exponential curve here. I think when I agreed to do this talk, it was like last year, and you know, we were actually in a very different world then. Before all the coding models started getting really good, before we started being able to do like 7, 8 hour tasks. Um, and so the future is basically being written as we talk. But I think there's some trends that you can start extrapolating based off of what you've seen. And so if the main question is where do we go from here? Coding and software engineering, I think, gives us the best early signals of where things are going. There are a couple of reasons for this. One is, in a world where you can apply RL to large language models, what was very important was to have tasks where the model work could be very easily verifiable and very easily gradable. And so math, obviously was a very good domain for this. That was kind of the first toy, or not toy, but like first academic application of this. But turns out software engineering and coding is also very verifiable, and is also a really great type of work that you can use to apply RL optimization pressure to. And so that is, it's not a coincidence that that is kind of become the first area where the reasoning models have gotten really good. The second thing too is for all of the research labs. We code a lot, and so we find it all. Google, Anthropic, OpenAI, we all find it very valuable to create models that are good at coding, so that it helps benefit ourselves and helps speed ourselves up. And so there's also a like market slash like practical consideration for coding. But the end result is that coding as a field, software engineering as a field, has really been the one that is I think seeing the future of where agents are going the fastest. And I think the clearest articulation of this, in my mind, is how software development and the tools you use for software development has changed over time. So this is a screenshot of VS Code. This is, how I was coding maybe 5 years ago. The entire screen is optimized for me as a software engineer, and the entire screen, the entire window is code. Then came cursor. So this is the same screenshot that I showed before. You'll notice that the code is no longer 100% of the screen. It's now maybe 60, 70% of the screen, and you actually have a sizable 30, 40% side of the screen that is talking to an AI and talking to a model about your code, and having it do things for you, having it asking it things about your code. Next came, I think, the coding products. So Claude Code, Codex, all of these. This is a screenshot of the Codex app. And this is actually what I use mostly nowadays. And what you can notice here is actually we've now flipped it. So the code itself, the code that's actually changed is now, now that's in the 40%, the minority of the screen. And the majority of the screen now is talking to the AI, looking at all the different threads you have on the left, and really only looking at what the model has output for your code itself. And then the code itself is only 40% here, and then you might want to dive in later. But we've now it's kind of shifted towards we flipped now, so it's like 60-40, where 60% of the screen is more for the AI. And so the question for us then is what happens as that 40% gets smaller and smaller? You look at this trend, it goes from 0 to 60% of the screen pretty quickly. And my favorite analogy for this, which I actually think has is actually feels pretty accurate for how software engineering feels like right now, is the Sorcerer's Apprentice from Fantasia, the Disney thing. This is a short clip from it. You can kind of get a gist of it. If you haven't seen Sorcerer's Apprentice, I'd highly recommend it. It's a really funny short film. But it basically details Mickey stealing a sorcerer's hat. He's the apprentice of the sorcerer, and then he starts casting all these crazy spells and having these brooms do its work for him. But then obviously the way the story plays out is this clip is from when the broom is actually doing the work for Mickey quite well. It's like getting water from the fountain and dumping it somewhere. But he then creates two of them and have them reproduce. So there are now 2 or 3 brooms doing work. And then he goes to sleep. And then he comes back, and obviously chaos has happened, and There's flooding everywhere because they kept, like shoveling water from the fountain into the basement, and so it's a complete mess. And then the sorcerer comes back and fixes everything. And I think this is a really great analogy because this is kind of what AI coding feels like right now at this moment in time. And I think as it progresses better and better, I think this analogy will actually still hold, which is you're basically starting to command legions of agents to do things for you. But there's clearly a double-edged sword, right? Like the beginners, like right when I started doing this, I was kind of like the Mickey, where I would just ask the model to do things and kind of not really watch it and have it go off. And sometimes it would actually do harm. Like you have to kind of like create guardrails for these things and be thoughtful around how to use it. And there is a skill here, right? So in this short film, Mickey is the beginner. He has no idea what he's doing, causes a bunch of problems. And then the like old white beard sorcerer comes back and fixes everything because he actually knows how to command all of these things. I think there's going to be something similar to this happening, and we already see it happening, especially with software engineers, where some of my software engineers are already extreme experts at using these things, and some of them already, some of them are still learning and are caught on some of the sharp edges. And so the fundamental change here, if you extend beyond just software engineering, is the way in which we work will change. And I think the biggest thing will be we'll need to learn to work alongside and also in control of many, many agents. Just as Mickey had his like legions of brooms doing, water moving. I think a lot of us will have a bunch of different agents kind of working for us. And just like how the window itself kind of flipped from being majority for people, I think we might, find ourselves in a situation. Hopefully, it doesn't look as scary as this, but it's like one person's like us and a whole legion of different agents, and the percentage of work and the workplace and environments needed to cater towards humans will look very different because it'll likely need to cater much more for agents for the AI. And so the next question from this is what happens then as we start to optimize the world for agents, right? Like if we are in this world where the majority of the work being done is actually done by AI agents, does the software need to change? Do the tools need to change? Everything that we've built have been optimized for people. It probably looks quite different. And also the way in which we work was optimized for people. The way in which it might actually start changing in a world that we have for agents. And my favorite example of making this a little bit more concrete was an experiment that we did internally with a particular team, and we published a really great blog post around this. I'd actually recommend folks, to look up this blog. It's on our blog today, but we published it. I think this was like 2-3 weeks ago. A blog post that we called Harness Engineering, and the setup here is so one of my teams. They were building a new product. They were building a new 0 to 1 product. And we basically said, let's try an experiment. You're building a new product. No code exists yet. Let's do an experiment and force this team to only use AI to write code. So you're not allowed to, do manual coding anymore. You have to use Codex and you have to use these tools. And this is the constraint we're giving to this team. Let's see how it works. It might go horribly, but we might learn things as well. And so this team basically operated in this regime for around 6 months. And we wrote a blog post on some of the learnings here. And I would say the biggest learning kind of falls into this environment thing that I just talked about, which was when we forced this team to only work using coding agents and not write any manual code, and they were fully dependent on AI doing work for them. A lot of the work that they were doing became building the right tools and environments for the agents to work, and less of like actual manual coding now. And so, and so what happens when we force a team to use Codex 100% of the time? So to make this a little bit concrete, there are a couple things that they did. So one big item was, again, this comes back to the idea of context management. These models are so good and so smart already, but a lot of times they just like don't have the full context of everything. And part of why coding has worked so well is the coding repos that, software engineers work within tend to encapsulate a lot of context already. It's not all of it, but it's maybe 80-90% of it. And because the model has access to all of the coding repo, is actually able to do a lot of really great work. And so one very quick thing that happened with this team that was just only using Codex to do things is their job shifted into a really important of their job became basically taking the knowledge that was in their heads or business processes or business knowledge or product knowledge that was really in their heads. Maybe they got it from meetings, maybe they got it from their time working at the company. And they basically spend a lot of time encoding that into knowledge and putting it into the code base. And so what does it look like in practice? This was actually the directory structure that the team ended up arriving at, where they would have a whole series of markdown files. There are probably thousands and thousands of tokens here, maybe tens of thousands of tokens, where the team was, again, encoding its information that it might know about how to write design docs, how to actually develop here, product specs, so information about our customers that we didn't know, information about our product plans, the general product sense that we bring. All of these, they would use, obviously, Codex to auto-generate these, but the process was basically taking information out of their heads and encoding it into text that you can then put within the repository so that it was legible and visible to the model. Because otherwise, the model has no idea about these things. And yeah, so this diagram on the blog post is kind of a repeat of what I'd said before, which is anything that was not in the code base, Codex had no idea about. Tacit knowledge, Slack messages, Google Docs, all of that. And so the work of the software engineer, instead of writing code, ended up becoming this process of just encoding this information into the code base's markdown so that the model could actually end up using it. The second thing that was very interesting, so kind of going back to the Sorcerer's Apprentice analogy, is very quickly they realized that the model would kind of go off the rails if you just let it run completely wild, right? Like you just tell it to move water, and then it'll just keep doing that, and then it'll flood everything. And what they realized is what they needed to do is they needed to construct a constrained environment and give a lot of guardrails within the code base for the agents themselves. And so the system and the code architecture for how the repo was structured and how the different code, classes were defined and the abstraction layers that you're building ended up becoming 10x more important here. And it almost to the point of over-engineering because this was a very small team. This was a team of like 3 or 4 software engineers. When you usually have a team that small, you don't usually need to architect things this much because there's a lot of tribal knowledge, and you're kind of talking to each other, and you're getting all this implicit signal about how to do things, and you have all of your own experience that you're bringing in. And usually, you don't need to architect things this way unless you have teams of maybe hundreds of people working on a code base. But with Codex, it kind of feels like you have teams of hundreds of people working on your code base, and a lot of them lack context. And so the team spent a lot of time thinking about the actual architecture. We're going to have this like UI, directory, and we're going to completely abstract away the business logic. It's going to be the rendering side. We're going to have like a runtime. We're going to have a service, providers. We're going to be external utils. And the hard work and honestly like expertise style work of this code architecture and the system architecture ended up being crucial to actually writing code here because you were creating these rooms and these like guardrails for the model to operate within instead of letting it go completely haywire. The other thing, again, going back to context, so much time was spent just like giving the model the right context here. And so we actually ended up building a whole system to hook up our full observability stack so that we could actually expose it to Codex so that it could query and access things as it was building. And so, obviously this chart's pretty complicated, but the main thing here was the logs, the debugging logs and the production scale logs that the application would produce as it was running. We would pipe it into Codex, or we would give it as a tool to Codex so that Codex could use it so that it could actually write code, deploy it, see what would happen, see if there's an error, or see if it worked well, and then iterate from there. And so again, this was once again just like trying to get the model the right context because logs as you're running things are a really important input to software development. And so the summary of this that we saw, which was honestly like super mind blowing for us, was the most difficult challenges for us basically moved away from just writing code into becoming like environment designers, creating the feedback loops, creating the control systems, and creating the environment for these agents to work in. All in service of obviously building and maintaining software at scale. And so the work shifted away from just coding into like agent management And the mechanism, the tools in which we had to manage the agents largely depended on the environment and the feedback loops that we gave it. And so this is all like kind of coming into a trend where I feel like for the next 3 years, the world around the LLM itself is starting to become extremely, extremely important. And what this might end up looking like is something like this. So this is a diagram that I've shamelessly stolen from my old coworker Andrei Karpathy, where he describes the end state as something like an operating system for LLMs. And there's actually a lot of really cool parallels between the different abstractions and tools and concepts in LLM development and actual operating system computers now, right? Because you have the LLM as your CPU, your context window is RAM. But the important thing and the reason why I wanted to show this diagram is everything outside of the LLM. And actually, if you look at the diagram itself, there's actually most of the complexity and interesting stuff is actually happening outside. And in software development and in computers and operating systems today, it's the tools and the things that the CPU runs on that's actually the most interesting. So, you'll have a file system, you have disk, you have a bunch of tools that you give it. You have a bunch of I/O devices for input of video, input of audio. You give it access to the internet, so it now has access to like other computers and other file systems. And I actually think this diagram is probably more correct than it is wrong based off of what we've seen. And we were kind of starting to see this already, where especially with the harness engineering example that I just showed, a lot of the interesting work is at the edges here of what tools we end up exposing and giving to the model. And so, the question then is like, what does the file system look like, the tool set look like, and the environment look like for agents of the future? It's really hard to predict. But what we've seen time and time again is different verticals, different areas kind of having specific use cases. So I just kind of walk through what coding might look like, but we're starting to see this work quite well for other domains as well. So like, what does this look like maybe for like Excel? What tools do like financial analysts might need to use these models in Excel? What do data scientists need? What do at OpenAI, our people team, our like HR team, our recruiting team ends up using this quite a lot. What do the set of tools look like for recruiting and for HR? What does the tool look like for students, for teachers? I think that is where all of the attention and interesting work is going to go over the next 3 years. As the models get smarter and smarter. One interesting trend that we've seen that I wanted to call out too is, when I mentioned that the models eat scaffolding for breakfast, the implicit thing there is that the tools and abstractions of today are also probably going to be outdated very soon. So today, MCPs are popular. Vector stores less so. They're kind of on their way out. But they're still kind of used, but MCPs are kind of used. And then skills and file-based context is very cool. But these will also likely become outdated. And I don't know what the right abstractions in the future will look like, but what I do know is there's a very good chance that skills and even file-based work might not end up being the final abstraction that we end up using to interact with these models. And there's an interesting line of thinking now, which is basically that code is all you need. So this is why Codex has become so popular. This is why Anthropic created Cowork as a general product on top of their coding harness. Turns out code is very general, and you can use code to do a bunch of different things. And one observation here is actually, so MCPs, which were the hot thing a year and a half ago, turns out there's a lot of limitations with it. And it turns out that if these models are getting so good at coding, and code is a very general substrate that a lot of work can be done, command line interfaces and just like programs that you give to the model. So CLIs, so like grep is a CLI, where you can just run a program to search things, and your model can actually write a program to use that program. CLIs end up being quite useful. And so one really interesting trend we're seeing right now is a lot of the companies that built MCPs in the last year for their own different services and their own products, they're now switching to building a command line interface that you can then run and give the model access to, so that the model can actually write programs against as well. And that actually ends up working even better than MCPs. And so the field is moving. It's always a moving target. It's always hard to kind of predict what's happening. But I think coding and what we've seen there is a good harbinger. And so to wrap things up, the last, I think I have like 5 minutes or 3 minutes or so left. I wanted to share more speculative things, like what if we go even further out? What are the interesting research directions that I see that I'm excited about? So I'll kind of share those before wrapping up. So one really interesting idea that has emerged recently is so I talked about, completion-based models. Then I talked about chat-based models with ChatGPT. The reasoning models today still are chat-based. So if you look at Codex, if you look at a lot of these agent things, you're still talking to it. But one question that one might ask is, why do we even have turns anymore, right? Like these models can work for 12 hours on things now. I don't really want to, if I start a task at 6 p.m., or 3 p.m., I don't want to have to wake up at 3 a.m. to like finish the turn and like observe the outputs there. The concept of turns almost feels like an outdated concept now. And so what happens if the model is just running 24/7, the agent's running 24/7? And I think the clearest product articulation of this that I've seen is this product that went viral around a month ago called OpenClaw, which is a very simple concept. It basically says, what if you had your agent? There's really no concept of turns anymore. It's just running 24/7 for you. Obviously, this if you're using one of our APIs, this will rack up quite a bit of money, quite a bit of cost. And so this has spurred a trend of, obviously people buying their own hardware and running local models. They're less smart, but you can at least run it 24/7. The cost isn't prohibitive. But OpenClaw explores this, and it basically says, like, if there's no turns anymore and you have a model running 24/7, all the abstractions and tools change once again, right? Like the input into the model might no longer look like a turn or a message from a user. You might actually ask the model to just constantly pull some input queue of tasks, and then you're just queuing tasks to the model and having it crank on things. The model's working for 12 hours on something, you might actually want to queue up a bunch of messages for something for it to do later. And so OpenClaw actually started showing the promise of this. I personally have not trusted the models enough to do this, because you can have this 24/7 running agent and it can send emails for you, it can send text messages for you. But a lot of people are doing it. And as the models get better, I've learned to never say the models can't do anything, but as the models get better, you could see a world where everyone basically has their own personal GPU, their own personal model running in the cloud, and the concept of turns is completely outdated now. And the question then is, like, do you only have one of these running for you? Do you have two of them? Do you have 10 of them? Yeah. So you might have your own personal GPU here. The next thing that I think is interesting to think about is, how far can we push RL scaling? So I'd said the big breakthrough of this reasoning era is applying RL to these language models and having it work. You need to, the catch right now is the domains where this works really well are in tasks where you can easily verify progress and verify correctness. Math is a very easy, is the most obvious one here. It's not easy, but by any means, but it's the most obvious because it's quite verifiable. And so one really interesting question is, how far can we push these? And I think this has huge implications for academia. Some of our own experiments internally to do this, and a lot of other frontier labs experiments to do this, is to push how smart these models can get at math. And like, can it actually reach a point where it's doing novel research for you, novel math research, physics research for you? I spent a lot of time in high school doing math competitions, and I never could get good enough to become an IMO qualifier, and I could never be good enough to get a gold medal at IMO. But the models nowadays, if you apply enough optimization pressure on math domain, can actually start getting gold medals at IMO, which is pretty crazy. So it turns out we can push this quite a bit, but the frontier is pretty far here. And so we're going to continue pushing that and seeing how far we can get. The other obvious one, what other domains other than coding fall easily into the RL paradigm? Coding is obviously the first one. On the API, we've offered a product called reinforcement fine-tuning, which allows companies to basically do RL training on our models, which has allowed us to really allowed us to have a very interesting perspective on the different domains that where this can actually work. So we've seen usage in areas like medical insurance coding. Turns out it's a very complicated process to take an output of a doctor diagnosis and turn that into an actual code, like CR7 or something, to give to medical insurance companies. But it is very verifiable. So medical insurance coding, tax analysis is one of those. Verification for chip design is very verifiable. Uh, uh, Coding, of course, as well, like compile time passing code are domains that we've seen. Another question is, why do we have to limit ourselves to verifiable tasks? Right now it is an inherent limitation because if it's not easily verifiable, the model just won't learn as well. It could easily hack it as well. But how can we apply RL to domains with tasks that are harder to verify? And so there's a lot of really interesting research right now around graders. When you have a model do a rollout in an RL environment, how do you actually decide whether or not it's doing the right thing, especially when it's very hard to grade the work of the model? If you have the model do some creative writing, how do you grade that this is, novel-worthy prose versus AI slop? It's kind of a hard problem. But as we do more research here and as we get better, I think the set of domains that we can apply will increase as well. And then the most active area of research that there's a lot of attention to is, RL is great, but how do we help the model learn from its interactions? After RL, the model learns a bunch and then it's kind of frozen in time. And then you have, Codex and the model GPT 5.3 that you have is a frozen model. It's actually not changing. The weights are not changing over time. But what you really want, is you want to treat these models really like interns or real employees where they come in, they have a bunch of knowledge baked in, obviously they pass the interview, so they're pretty smart. But you want to give them a bunch of guidance and have them update the way in which they work. You want that encoded somehow in the weights themselves or via some other mechanism. And so the idea of continual learning and having the model learn from its interactions live as it's interacting with the world post, a big RL training is the other interesting area that we've seen. So to kind of end things, I wanted to go back to the meter graph again. So, everything I described has actually all happened in the last 3 to 4 months around coding. And it's because these models have moved from being able to do 2-3 hour tasks to basically do 12-hour tasks at this point. The future is still, there's still a lot ahead of us. This chart is kind of bonkers to look at because, and I had to shrink it on the slide. It was like, what happens over the next 3 years? This giant gray area, I might not even have shrunk the graph enough because this giant gray area, there's like 20 hours, there's like 1 week long tasks that people might do that might actually be in the future here. And so while this may be super, crazy, intimidating, kind of like scary, because change is always scary, my personal take is I think the future has never been more exciting. I think the way in which we're working is drastically changing. I think it's an incredible privilege for all of us to be living in a world and doing research and thinking about a world where a lot of the paradigms are changing. It's incredibly empowering for us, but it is nerve-wracking as well. And so the thing I wanted to leave everyone with is so my favorite Calvin and Hobbes comic. It's the very last comic actually in all of Calvin and Hobbes that Bill Watterson drew. And it's basically showing Calvin and Hobbes. It's a snow day. I know you all in Florida probably never, don't really understand this, but, believe it or not, it can snow enough where school gets canceled and you just get to play outside all day. It's a snow day. And Calvin and Hobbes are out there. They look out at the giant snow landscape and they view it as a giant white piece of paper. It's full of possibilities. And the final slide is Calvin and Hobbes, on the sled, going exploring into the wilderness. And so it's a crazy time right now. Things are changing, but I hope we can all see the excitement and the potential and the optimism here because it's going to be very exciting to go exploring in this space over the next 2 to 3 years. Cool. Thank you.
Thank you so much, Sherwin, for this wonderful sharing. As you can see, actually, he's in California time, so it's he could just woke up at 6 a.m. and give this talk there, which is really amazing. Really appreciate. So yeah, so appreciative. I imagine he was hardworking, sent us the slides, final version like last night, 12 p.m., like 3 a.m. in California. So I mean, I can also
I had to work on them after work.
learn what is the insights that can be provided by this top-notch engineer in the field. So I think we do have a few minutes for question answering. So if you have any questions that you think might want to directly ask Sherwin, please do.
My question is related to the reasoning models. Another way to understand them is to ask the 10 model generate many choices, then choose the best one. And what is the missing in this naive understanding compared to the reasoning models that are really being developed maybe in the future? Thank you.
Yeah, so I what the reasoning models really are doing, so there's like a train time component to the reasoning models, and then there's like a inference time. And the way what you just described of like having the model explore and search and do a bunch of different explorations and judge a bunch of different options is basically how we train the models at train time for this reasoning paradigm. But what the ambition of training these models is to allow them to explore and try a bunch of different options and search a bunch of different options, but then have the model be good at doing the right ones, right? So like it can explore a bunch, but then and then this is kind of what we're seeing the models get better at. And so this like concept of searching that you just described of there are a bunch of different things that you can do, and then have the model you can have the model like search a lot of these. We really try and have the model do at train time, and then at test time at like once you're actually talking to these models, the ambition is that the models are well trained enough now where it actually knows what to search and it can arrive at it in a much more efficient way. I don't know if that exactly answers your question, but that's the way that I would personally think about the whole reasoning setup.
I have one more question there.
I wanted to quickly go back to your analogy. I really love the Sorcerer's Apprentice. So there are two things that I didn't hear you say, and I wanted to ask about it. Number one, Mickey didn't just go to sleep and suddenly everything was different. He actually chopped the broom to try to kill it, and that created additional brooms. That's
Yeah.
one. The other one is, who is the sorcerer here? And where are we going to find him when we need him?
So yeah, so I actually think the whole like Mickey trying to stop it and then the like combinational explosion thing I think is like very important, and that's why I actually think it's like a really great like the analogy has like more truth to it than it has any right to, where like if you're not careful with these models, and also if these models are not built in a way that are well aligned and safe enough, things can get pretty crazy. Things can get pretty weird. And so, I mean, I don't want to spend too much time on this, but there's a lot of interesting research and work happening right now around like how do we actually steer the model, like on alignment and safety, and how do we steer the models to do the right things so that this kind of like crazy takeoff thing doesn't end up happening. But I think the analogy there still holds, which is you need to be like it's clearly a double-edged sword, and you need to be very careful with how you use these models, and just being irresponsible. Like there's a lot of power in these things right now, and just being irresponsible and kind of like letting it run wild and do things for you might end up creating outcomes that you don't want. Your second question of who's the sorcerer, that's kind of where the agency and the interesting component comes in, which is I think the challenge is for us to become the sorcerers, right? Like we don't actually know how to. And actually maybe to put it in a little bit more concrete terms, I actually think what's already happening at a company like OpenAI is this technology is slowly getting diffused by the engineering organization. So I would actually say they're a subset of engineers who have used this technology and like really steeped themselves in it for long enough that I would actually consider them to be the like masters and the sorcerers of these things. They kind of understand what's happening. And so they know the best way of how to like give the thing guardrails. They know how to like, work with it and make it be productive. They know how to like best walk it back when it did things that it shouldn't actually have to do. And there are a lot of people, myself included, that I think are more beginners on this thing, where we're still trying to figure things out.
I just have one final question, just like on top of my head. This morning when I watched your interview in the podcast with Lenny, you mentioned that there's a notion of one person, $1 billion company that's going to be coming up next. So how soon are we going to be getting to that point where we see a lot of new startup with only one or two people?
Yeah. So on the podcast, I was talking about how that's a very like popular thing to say, like a one-person $1 billion company. My general take, and I didn't get a chance to share this in the talk, is one observation is I actually think the the rate in which this technology will diffuse through society is going to significantly trail the actual capabilities of it. Like we're already seeing this, which is in most corporations, this technology hasn't actually like permeated it and changed the way in which people work that much. It's really just like a small bleeding edge of people. And so to answer your question, I think it'll be a very long time until we get this, but I think you can start seeing the trends and extrapolating all this. The one other thing I'd say is in the podcast, I try to say, it's very fashionable to talk about the $1 billion startup because $1 billion is a lot of money. But what I'm actually personally more excited about is, I don't think there's gonna be very many of those. I think there's gonna be like maybe like, I don't know, a handful of like, you can't have that many $1 billion startups. But what I think is gonna be more interesting is as these agents get better and they can do more work for you, and you can end up feeling like a sorcerer who actually knows what they're doing. I think there's going to be like a huge explosion of $10 million startups or $100 million startups or even like $5 million startups. $5 million startups are huge. That's like you're running a great business at that point. I think all of that will be a lot more possible, and I think it'll be a lot easier to do with a lot of these tools. And so while $1 billion is like it's a lot of money. I actually think there's gonna be a lot more of the smaller ones that are still large enough for people to kind of have their own business and have their own make their own living there.
Thanks so much, Sherwin. Let's give them a big round of applause. And that's also great. That's coming from over there.
Thank you.
Thanks so much, Sherwin, for joining us this morning. Appreciate it.